This is kind of an interesting one here. This is a brand new Lennox unit that keeps eating up the belts, and quite a few techs have been out here and done different things, and my supervisor just made a decision to change this to a 2-belt system. So, you know, it is a little bit of a judgment call. You know, it's kind of hard to prove what exactly is going on, but this is a very, well, I shouldn't say very, way bigger than this, but this is a good size blower assembly, and this motor is not on a drive. So to take this thing, you know, from 0 to 60 with a motor like that, that's liable to do a lot of wear and tear on a single belt. So I'm gonna just show the process of going in here and making this a double belt system. Before I take this belt off, let me just mention, you know, a lot of things have been checked. Yes, alignment has been checked. All of that crap has been checked. And you can see that this belt is loose, but they don't start that way. I know for a fact that every tech that's come out here and messed with it, they start with a very, very tight belt. Normally I could slide this assembly all the way out. These installers were generous enough, see, look at that, they were generous enough to give us enough clearance to barely get it out. So typical. But anyway, sliding this thing out is gonna help quite a bit. The very first thing I'm gonna do here, well, first thing I did was remove that door. This gives me a little more space, not totally necessary. See the pins that enable the bolts to push this down have been sheared off. So I'm gonna try to do something about that first and get this working before I go and put on the pulleys, which I already checked, or sheaves I should say. I already checked, and they are the right size, so everything looks compatible. So this one here came out just fine. By the way, I'm not exactly sure how or when this happened. My guess is someone was just trying to, I don't know, get it tight, or God, who knows. This one had a little weld bead on there to try to keep it in place. I'm sure to strip the nut out, so I'm gonna have to figure out what I'm gonna do about that. But other than that, ugh. I don't know why you would need this to be captive. I mean, why does it matter? Why wouldn't you just make it so you can take the bolt out? I have no idea. Picked these up recently on eBay. This is the SAE model, and pretty sure they're made in the USA. This is the metric, but really kind of nice thread gauges, so that gives you your diameter, and it's a pretty nice fit. And then there's your pitch, half 13. So I'll see if I have the hardware, or might just go get some hardware. I'm not sure why they didn't put a washer on top there. You would think that would be a good thing to do. Couple tips here. You can cut aluminum angle to give your vise some soft jaws. It's better for threads and brass fittings. Now I have a set of roll pin punches in my shop, but I don't have them with me. But they have like a little dimple on the end there that fits in this hole. This one is okay, so we'll just try to drive it out. One thing I'm really not a fan of is how much slop was in these washers, because it'll have a tendency to put more pressure than necessary on those roll pins, as far as just bending them. So gonna get these and drill them out just a bit. And the best way to do that, to grab this, is probably to use an impact, although definitely wear safety glasses. But I'm just putting them in a Swedish style pipe wrench so that I can put a little pressure down. That'll get a good bite on them. That's going to be a much better washer. And I am going to add one to the top if I have room. Got them fitting nice and snug. The reason the impact's such a good option is because it puts a lot of energy into turning the bit or driver and not much into the object, unlike a drill. So the washer's a lot less likely to spin now. I don't know if I have room, I hope I do, to put one up top, but we'll see. Use this little grinder here, which by the way works way better with these diamond wheels, but just to grind that weld bead off and then re-threaded it. So now let's put our assembly back together. It's a little janky, but sometimes you just have to work with what you have on hand. Just using these wall anchors, nice pointed tip, just hammering those in there, and then I'm gonna cut them down. I was able to get another washer up there. It did reduce a lot of my play, so hopefully I don't have a problem getting these threaded. But it is much tighter and much nicer than it was from the factory. Let me get these cut off. I really like these by Irwin. They come in a set for big and small taps, but they allow you to use a ratchet wrench on your taps. Now, this thing that I'm repairing, it's not structural. What it's for is to raise and lower this sled to adjust tension. So ideally I would have liked to have brazed a new nut in there, but I'm gonna tap it first and just see if it looks like it has enough thread on it to work, and then we'll go from there. Well, she is kind of gnarly, but should have enough thread there to raise and lower this motor. What I think happened is someone was messing with these without having these bolts here loose. Aren't you focusing? Without having these bolts here loose, and that's probably what did the damage. But with these bolts loose, we should have plenty of thread to just raise and lower this just fine. Okay, good as new. Or should I say good enough? Maybe it's just good enough. I'm getting ready to do my alignment here, and one thing that's important is you want to see if these pulleys are the same width, or sheaves I should say, and they are. If they weren't, then you would have to be careful with your straight edge and realize that one of these is going to be offset from the other one. But in this case, we'll just take a straight edge all the way across and make sure the alignment is good. A couple of tips on these. So when you go to tighten this, what it's actually doing is digging into that shaft. So I like to tighten it, back it off, and then tighten it again, and then sometimes again, and that just helps it sink down in there. Now, this style of sheave can be kind of hard to align because it's only until you tighten these and get this clamped that it gets in its final position. Now, the easiest thing to do is to adjust that one and then come back and adjust this one, but I don't have much play with this one at all. So I've just kind of fixed it where it should go, and I'm gonna come in here with the straight edge. Now I've already gotten this tight, okay? And I'm gonna see where I'm at, and then I'm gonna measure that and put a mark down here on the shaft, and that will tell me where to put this collar so that when everything's tightened up, it'll all be very nicely aligned. Okay, so here's where my sleeve was. And I need to move it to here and then cinch these up and everything should be aligned. Okay, the alignment's looking very good now. So I'm happy with that. Let's get the belt on. All right, now, if this belt slips, I will be shocked. But I get everything nice and tensioned. So now all we got to do is shove it back in there, make sure our amp draw is good, and see how she runs. Got the old Prodigy in test mode. I'm over amping a bit, and it's not terrible. But I'm not a huge fan of that double belt. It's like a high torque belt. I'm gonna get some normal belts and put them on there and see what happens. Amperage kind of jumping around. I got some interference in here. There you go. Yeah, she's doing quite a bit better with just a normal belt and not a high torque belt. Those high torque belts are just real thick and stiff, and I think that was causing a lot of issues. So I'm within range now. I think we're good to go.